When you operate a CNC machine, every fraction of a millimeter matters. Even a small drift outside specification can lead to scrap parts, missed deadlines, and dissatisfied customers. Imagine running a long production batch only to discover that a slightly misaligned axis has ruined the entire lot. This is why CNC machine accuracy is not optional. It is the safety net that protects your work, your time, and your reputation. Many operators believe modern CNC machines are already accurate enough, but small errors often accumulate over time. Environmental changes, worn components, and overlooked maintenance slowly reduce precision. Even tiny deviations can affect part fit, surface finish, or functional performance, especially in tight tolerance applications. Accuracy also directly affects your credibility as a manufacturer. Customers in industries such as automotive, medical, aerospace, and mold making expect parts that meet exact specifications every time. Inconsistent accuracy leads to rejected parts, lost trust, and potentially lost contracts. Maintaining accuracy is not just about machine performance, it is about protecting your business. By prioritizing CNC machine accuracy testing, you are not just checking measurements. You are ensuring consistent quality, reducing scrap, increasing confidence in your process, and supporting long-term business growth. Accuracy directly impacts your bottom line, your reliability, and your ability to scale production. Several key factors influence CNC machine accuracy, and ignoring any of them increases the risk of errors. Machine build quality plays a major role, as components such as ball screws, linear guides, spindle design, and frame rigidity determine how precisely the machine moves and holds position. Machines built with higher quality components maintain accuracy longer and provide more repeatable results. Environmental conditions also affect accuracy more than many people realize. Temperature changes, humidity, and vibrations from nearby equipment can shift machine geometry over time. Controlling the workshop environment through temperature stabilization, vibration isolation, and proper machine placement significantly improves consistent performance. Tool wear and maintenance are equally important. Worn cutting tools, spindle runout, and poor lubrication all reduce accuracy even on high-end machines. Regular inspection of tools, checking spindle condition, and following a consistent maintenance schedule help maintain stable machining results. Operator skill and software settings complete the accuracy equation. Even the most advanced CNC machine requires correct parameter selection, accurate workpiece zeroing, proper offset handling, and regular calibration. Errors introduced at setup or in software settings often appear before the first cut is made. Accuracy testing is essential if you want your CNC machine to consistently produce parts that meet specifications. Standardized testing methods provide reliable ways to measure and verify machine performance. International standards such as ISO 230 and VDI or DGQ define clear benchmarks for positioning accuracy and repeatability, allowing results to be compared objectively across machines. Laser interferometer testing is commonly used for high-precision applications because it measures linear positioning errors at the micron level and reveals subtle axis deviations that are not visible during normal machining. Ball bar testing is widely used as a fast and effective method to evaluate circular interpolation accuracy and identify issues such as backlash, servo mismatch, or geometric errors. Touch probes and probing systems allow quick verification of workpiece setup, tool offsets, and repeatability directly on the machine, reducing setup errors and preventing scrap. Repeatability and backlash checks on each axis help confirm that the machine consistently reaches the same position under identical commands. A structured accuracy testing procedure helps ensure reliable results. The process begins with thorough machine cleaning, removal of chips and fluids, and a proper warm-up period to stabilize thermal expansion. Environmental conditions such as temperature, humidity, and vibration should also be verified before testing begins. Axis alignment and squareness should be checked to ensure correct geometry between X, Y, and Z axes. Spindle runout measurements help confirm concentricity and rotational stability. Linear positioning and repeatability tests compare commanded positions to actual movement, while circular interpolation tests reveal motion errors during arc movements. All measurement data should be recorded and compared against accepted standards. If deviations are detected, calibration and parameter adjustments are performed, followed by repeat testing to confirm corrections. This process helps catch small issues early before they turn into major production problems. By testing CNC machine accuracy regularly and understanding the factors that affect it, you maintain consistent quality, reduce downtime, and protect both your equipment and your reputation. Accuracy matters because it defines the reliability of every part you produce. If this explanation helped you, like the video and subscribe for more practical CNC troubleshooting.